In this video, I'm going to be offering support for Module 3, pages 139 to 143. Again, the learning goals for this section are to be able to write and solve two-step equations, compare linear problem situations. That's a tricky one. Rewrite expressions in different forms in problem context in order to interpret how quantities are related. That's a little tricky. Compare graphs of linear problem situations. That won't be too bad. Compare and interpret forms of a linear equation. That's still a little tricky at this time frame. And so, again, the main form that we're working with is slope-intercept form. Slope-intercept. And again, just as the name describes, you're just looking for the slope and the y-intercept. It is y equals mx plus b, and you're looking for slope, which is m, and the y-intercept, which is b, hence slope-intercept form. Let's take a look at the warm-up problems. Use properties to rewrite. And we're just trying to simplify, because again, these are expressions. There's no equal sign, there's no inequality signs. These are just expressions, and all we can do with expressions is simplify them. 3, open parenthesis, x minus 1. Well, a property I can use is to distribute. I can multiply that 3 times every term in the parenthesis. 3 times x is 3x. 3 times negative 1, positive times negative is negative. 3 times 1, 3. I can't combine these terms because they're not like terms. This has an x and this doesn't. So that's as far as I can simplify that. Number 2, negative 9, open parenthesis, negative 2 plus x, close parenthesis. I'm going to distribute this negative 9 into the parentheses. Negative 9 times negative 2, negative times negative, or another way of saying it is, the opposite of a negative is a positive. 9 times 2 is 18. Negative 9 times positive x. Negative times positive is negative. 9 times x is 9x. So 18 minus 9x, or 18 negative 9x, is simplified. Again, I cannot combine these terms. They are not like terms. Like terms mean they have the same variables. Number 3, 1/2, open parenthesis, x minus 6. We're going to follow that same pattern. We're just going to multiply into the parenthesis. 1/2 times x, or half of x, is just 1/2 x. 1/2 times negative 6, positive times negative is negative, and half of 6 is 3. And again, that would have looked like 1/2 times negative 6. I'm just going to put the negative 6 over 1. And 1 times negative 6 in the numerator is negative 6. 2 times 1 in the denominator is a positive 2. Negative 6 divided by positive 2, negative 3. So that's where that negative 3. On number 4, 6 plus 3, open parenthesis, x plus 4, close parenthesis. Order of operations, I can't combine these terms in the parentheses. These are not like terms. I'm going to multiply or distribute then into the parentheses. The 6 is still the same. 6 plus 3 times x is 3x. 3 times 4 is 12. I'm going to need to combine, because 6 and 12 are like terms. A step that often gets ignored, I'm going to include it here just because it is part of the properties. We often just go straight to combining 6 and 12 and saying it's 18. But mathematically, the step before that would be to, actually I'm going to commute this side. I'm going to do the commutative property of addition and rewrite this as 3x plus 6. So I use the commutative property of addition on 6 and a 3x to change the order. And again, commute is to go back and forth. You commute to and from school. Commutative property just means you can change the place of the numbers or the terms on each side of an addition sign or each side of a multiplication sign. And this positive 12 is still the same. Now I can combine like terms. 6 and 12 add up to a positive 18, and I have 3x plus that 18. So obviously somewhere in this section, you're going to be using the distributive property, and so that's why they're foreshadowing with a reminder of how to do this warm-up. Let's take a look at the next page. Learning the limo business. Katie is starting her own limousine rental company. She wisely decides to check her competitors' pricing plans before setting her own plan. The table shows the fees of the two rival limousine rental companies. Examine the fee schedule for the two limousine companies provided in the table. And so her competitors are Limousines by Lily. I'm going to designate that. Anytime I say that, I'm going to use LL. And the other company is Transportation with Class. I'm just going to go write TC so I don't have to write out the whole word Transportation with Class. So let's take a look at her at who she's competing against. First, number of hours rented in the table in the chart. Let's just look at Limousines by Lily. The first hour costs $99.99, and then the next hour is $123.74. The next is $147.49. 4 hours, $171.24. So obviously it's more expensive for the first hour, but then it's going up by a rate. I want to see if this is the same rate each time. So I'm going to find the difference between 123.74 and 99. 123, I'm using my calculator just because it's friendly, 0.74 minus 99.99. It went up $23.75. I want to see if that's consistent. So I'm going to take 23.75 and add it to this. So 23.75 plus 123.74, and I get, on my calculator, 147.49. So this also went up by 23.75. So it looks like her rate of increase after that first hour, and here it is the same, plus 23.75, and it's the same here, plus 23.75. So her rate of increase is 23.75. So she's charging $99.99 for the first hour, and then every additional hour is $23.75. Transportation with Class. Well, if you're only renting for 1 hour, it's $10 cheaper. It's $89.99. But then at the second hour, it's up to $126.54, so it's a little more expensive. And then each additional hour after that, it seems to be going up by a greater amount. So it looks like she has a cheaper rate, or they have a cheaper rate for first hour, but their hourly rate is more expensive. Let's find out what their hourly rate is and make sure it's consistent. So I'm going to find how much this went up by. So I'm going to go 126.54 minus 89.99, and I get 36.55. And is that consistent? Does this, going from 2 hours to 3 hours, does that also go up by 36.55? So I'm going to go 36.55 plus 126.54, and I get 163.09, so it did. And then does it go up the same? Yes, it does. Plus 36.55, and then plus 36.55. So Transportation with Class starts cheaper, but has a more expensive hourly rate than Limousines by Lily. And Katie, whatever she decides, that's IE for Katie, she's going to have to come up with her own rate that's competitive with these two companies, and she still needs to make money because it's a business. So let's take a look. So that's what's happening up there. Which limousine company would you choose if you were renting a limousine, and then support your answer with information from the table? Well, can we agree that if I'm renting the limousine for an hour or less, actually, 2 hours or less? Nope, just 1 hour. 1 hour or less transportation with class is the better deal. But if I plan on renting the limousine for more than 2 hours, then I'd want to go with Limousines by Lilly. So if I'm renting, I'm going to do shorthand and write limo as opposed to limousine. Limo for 1 hour or less, then I will rent from Transportation with Class. I'm putting TC because I did my designation there that TC was Transportation with Class. But if I'm renting for 2 or more hours, then Limousines by Lilly, and again, I use my LL for Limousines by Lilly, is the better deal. So, and this provides both companies offer the same service, the same type of limousines, etc. That you're not choosing one because one has newer, more luxurious limousines than the other. This applies that the company's cars and their customer service is fundamentally the same. So in this case, again, our rate for Limousines by Lilly, her slope or her rate of increase is 23.75. But what's going to come into play in the sections in the pages to come is the first hour costs $99.99, and then it goes up every hour after the first hour goes up by $23.75. Writing a set equation that takes the first hour into account, because if I just said her rate is $23.75 and she charges $99.99 for the first hour, then a lot of people would add those two together and they would say, hey, the first hour costs $99.99 plus $23.75. Hey, the first hour would be $123.74. And that's not the case. So we have to figure out how to write an equation for this. And I'm going to do a little foreshadowing. If we subtract $23.75 from $99.99, how much is that? Turn on my handy calculator. 99.99 minus 23.75, 76.24. Slope-intercept form for Limousines by Lilly. Her output is her rate, 23.75 times the input value, plus 76.24. That way, this takes into account the very first hour. I can put a 1 in for X and get $99.99. And in the pages to come, they're going to show you how to do this mathematically, as opposed to I just figured out and subtracted it. They're going to show you a quick formula to use. And similarly, Transportation with Class, TC. Again, the rate for that company, Y equals 36.55 an hour, and then their initial charge. Now, normally it would be $89.99, but again, if they're charging $36.55 an hour, I'm going to subtract that $36.55 from $89.99. 89.99 minus 36.55, 53.44. And in our equation, y is total cost, or total fee or charge, and x is number of hours of rental. And we've put both of those into slope-intercept form, just using a little common sense and some trial and error. And again, we're going to be showing in pages to come how to do it with an equation or with a formula. So, this is who she's competing against. Let's take a look at the next page. Katie starts by analyzing the cost structure of limousines by Lily. Consider the cost of renting a limousine by Lily. What is the first hour of rental from Lily's cost? Well, her first hour in the chart, 1 hour is $99.99. 1 hour equals $99.99. What does each additional rental hour cost from Limousines by Lily after the first hour? Each hour, raise the cost by $23.75. And again, we have already figured that out on this first page. So I'm not just magically coming up with that number. The increase is this $23.75 per hour. What would it cost to rent a limo from Limousines by Lily for 10 hours? And explain your reasoning. Well, again, it's $99.99 for the first hour. After to go up to 10 hours, there's 9 more hours, because if this is the first hour, hours 2, 3, 4, 5, 6, 7, 8, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's another 9 hours there. And so we're going to have to add plus 9 times the cost per hour, 23.75. And again, this is where calculators come in handy. 9 times 23.75, $213.75. And to that, we're going to add 99. Oh, this is for hours 2 through 10. So that plus 99.99. The total fee would be $313.74 for 10 hours. And then on letter D, what would it cost to rent a limousine from Limousines by Lily for 13 hours? And explain your reasoning. Well, again, we have the charge of $99.99. That's first hour. Plus, we need 12 more hours, because we have to go 13 hours minus the 1, or 12 hours. And so that is our fee what is the fee? $23.75 times 12 hours. And $23.75 times 12, again, good use of calculators. 23.75 times 12 is $285. So this is $99.99 plus $285. And then the total cost, $384.99 for 13 hours. Explain how you calculated each cost. What did we do? We started with $99.99 for the first hour. And then we multiplied the rate by the number of hours remaining. And really, that's the total hours minus 1, because we just subtract away the first hour. So it's total hours minus 1, or hours minus 1. So the first hour, and then the rate, times hours minus 1. So it would look like, just like that. In this case, 99.99, that's her first hour, plus her rate, 23.75, times the total number of hours, minus 1. And if we distribute this, we'll be able to get any number of hours with that equation, or that expression. So hopefully, again, let me know if you have questions on this. Email me or text me through Remind. Let's take a look at page 142. Write an equation for the total cost, T, of renting a limousine by Lily for any number of hours. Oh, well, that's if T is the total cost. So let T equal total cost. And H equals number of hours rented. Then total cost is the first hour plus the rental charge, 23.75, H minus 1. So there's quite a bit of math in coming up with that. That is not an easy equation to come up with just off the top of your head. And this is really what we're going to be working with, is our ability to do this. That, like subtract the first hour, or the first of something for non-proportional relationships that don't perfectly start at 0, 0. So you can rewrite your equation for limousines by Lilly before using it to solve problems. Previously, you learned to simplify algebraic expressions using a variety of strategies. Rewrite your equation in the form ax plus b is c. Name the strategies necessary to rewrite the equation you wrote. So let's take a look at what we're given. And so we have, again, I'm going to use still my t's and h's, and I have my original t equals 99.99 plus 23.75 times h minus 1. I'm going to distribute. And I'm going to rewrite this as the total is 99.99 plus 2375 times h is 23.75h. And then 23.75 take away times negative 1. Positive times negative is negative. 2375 times 1 is 23.75. Well, on this side of the equation, I need to combine like terms. I've got 99.99, and I've got a negative 23.75. When I combine those, what is 99.99 minus 23.75? Well, I guess before I do that, I should probably commute these two. So I'm going to rewrite this as t equals 23.75 times h, the number of hours, plus 99.99 minus 23.75. I could do that by hand, but again, calculators are nice. 99.99 minus 23.75, 76.24. So t equals, here's our rate, 23.75 times h. 99.99 minus 23.75 is a positive 76.24. So I rewrote it. Oh, they want it just instead of t equals t. So I'm going to change the order. I'm going to reflect around this equal sign. So I'm going to write it as 23.75 times the number of hours plus 76.24 equals t. And now I'm of the form 23.75 times hours plus some starting amount gives me an output C, in this case, the total. The strategies I used, I distributed. I distributed property of multiplication. And we jumped over this subtraction sign. So we distributed through multiplication over a subtraction. So that is over subtraction. I commuted. Commutative property of, and I commuted around a plus sign of addition. And I combined like terms, so I simplified. Those were the strategies I used to turn this into this. Oh, I guess then I reflected. Reflected around the equal sign, because if x equals y, then y equals x. I can change the order in which they're written. So rewrite the equation you wrote for Limousines by Lilly. Explain the resulting equation. Explain why the resulting equation is a two-step equation. Well, t is my output. I want you to think back again. Y equals mx plus b. And this equation, 23.75h plus 76.24 equals t. It's a two-step equation because I'm going to have to undo addition. I have to get H alone. I'm going to have to undo addition, and I'm going to have to undo multiplication. I'm going to have to perform an addition property of equality. And again, I can adding a negative number to both sides as an addition property of equality, or to subtracting a positive number from both sides as a subtraction property of equality. But both can be listed. It's a property of equality. And I'm also going to have to undo this multiplication. So I can multiply by an inverse. And a multiplication property of equality. Compare the two equations you wrote for this company. What is the same? What is different? They're the same equation. They're going to, if you put in a value for the number of hours, you're going to get the same answer. They're just written differently. Write a possible fee scenario for Limousines by Lilly to match the rewritten equation. With this one, I'm going to write 23.75H plus 76.24 equals T. And again, same rules as above. My T is total cost, H is number of hours. So this one, there's a fee of $76.24 just for renting a limo regardless of hour, and then it's $23.75 for every hour you rent the limo for. So this is Limousines by Lilly. So LL charges a, what do we want to call it, a management fee? A booking fee, whatever you want to call it. But that's the fee, whether you rent it for, 1 hour or 2 hours, you have to pay that $76 plus the hourly rate. So plus an hourly rate of $23.75. So we wrote a possible fee scenario for Limousines by Lilly to match this rewritten equation. And then we're going to use this equation to calculate how many hours you rented for if your bill was $266.24. So if your total bill, so again, the equation is 23.75 times the number of hours plus 76.24 as a management fee or booking fee. And if your total bill was $266.24, we want to solve for H. So somewhere down below, we want H equals some number of hours. Well, this is where it's a two-step equation because I'm going to have to use both sets of properties as equalities. So I need to get H all alone. I take a look at H, and 7624 is being added. So I'm going to add a negative 76.24 to both sides, or I could also say I'm going to subtract 76.24 from both sides. 76.24 minus 76.24 just zeroed out. That became a 0. So I'm on this, I have my equation. Over here, I have my 23.75 times the number of hours, and then 266.24, this I'm using my calculator, minus 76.24 equals 190. So again, I need to get H all alone. H is being multiplied by 23.75. How do you undo multiplication? What undoes multiplication? But division. So we're going to divide both sides by 23.75. And we just did the division property of equality. 23.75 divided by 23.75, that's a fancy 1. I have 1H. That's what I'm after. And then on this side of the equal sign, 190 divided by 23.75 is 8. So if the total fee was $266.24, it means you rented the limousine for 8 hours. And again, on this page, there's a lot of mathematics taking place. If you have questions, obviously stop, go back through the video and just re-listen and see if it makes sense. You can also get a hold of me via remind, text, or email. I'd like you to try to do this, basically the same thing we just did for Limousines by Lily, but on page 143, see if you can do it for Transportation with Class. And I'll provide the answers for this page in a couple of days. Good luck, and I'll talk with you then.